Combining the virtues of all additional tools is a new system of measurement, the Nucleonic Gauge, which comprises a detector of radiation, in this example, a Geiger tube, and a radioactive source. Although the radioactivity of this source is little more than that of luminous paint, it will be seen that the associated meter is fully deflected. When a piece of paper is interposed between source and detector, a definite reduction in radiation is registered on the meter. When a piece of metal is similarly introduced, it will be seen that a proportionately greater reduction in radiation is indicated. Thus, we have a system of measurement with unusual advantages. We can, for instance, measure the density of liquids in closed containers. This example demonstrates the detection of liquid density change inside a cast iron pipe. A radioactive source mounted in a safety housing is clamped to one side of the pipe. On the other side is a detector. Colored paraffin floating on water is being pumped inside the pipe. The density change between the two liquids is registered on the associated meter. Industrially, this system is used to read changes in the passage of fluids or slurries through pipelines. Ekco Nucleonic Gauges are used for this purpose on major oil pipelines and with cement, clay or coal slurries, even in toothpaste manufacture. The rate of wear on moving engine parts can be established by radioactivating the part to be investigated and noting the degree of contamination of the associated lubricant. The circulating oil is pumped across a detector and the rate of contamination, that is, the rate of wear, continuously recorded. Periodic dismantling and reassembly of the engine is unnecessary. From these demonstrations, it can be seen that if we have a suitable radioactive source, a stable detector in the form of an ionization chamber, and an indicator, we can measure materials without touching them, and we can measure them in motion. Thus, we have a system of continuous measurement of weight per unit area of the wide range of materials produced in sheet form, of which plastics, rubber, and paper are examples. By mounting the source and the detector on parallel arms, which are capable of traversing movement, we can scan the whole width of continuously flowing material without touching them, and recording any variations in thickness or substance as the material is processed. If the manufacturing system does not permit the exposure of both faces of the material, we can measure its substance by reflection, sighting source and detector on the same side. Turning to examples of industrial practice, here is an industry which, in turning mountains of wood pulp into miles of paper, makes full use of nucleonic gauges. The machinery which carries out the process is among the largest used in industry, and the product ranges from the finest tissue to the toughest board. In face of ever-increasing output, the closest quality control must be maintained. Traditional methods of controlling the substance of the paper manufactured commences with a preliminary run until the desired standard is achieved. Then by the successive taking of samples from every finished roll. The method entails considerable waste. The samples are taken to the control laboratory. From each one, a tear-off is made to a standard size. The standard section is then referenced and weighed. Its substance is estimated on a weight per unit area basis. Further checks are made on thickness at a single point and then cross-sectionally. The Ekco Nucleonic Gauge brings control throughout the whole run within the province of the machine operator. The nucleonic head provides continuous measurement of the flowing material on an indicator which is situated adjacent to the machine, and so minimizes the otherwise inevitable production of substandard material. While the measuring head is situated at the point of the finished run, an indicator control unit may be positioned some distance away under the immediate observation of the supervising engineer. Provision of a nucleonic profiler gives a permanent record of the substance across the whole width of the paper. The unit accepts 9 to 12-inch tear-offs, feeds them through the measuring head, and records the run. When dealing with coated products like leather cloth, rubberized sheeting and the like, 2 measuring heads are used. One reads the uncoated and the other the coated material, measuring by difference the thickness of the coating. An example of close tolerance control by this method is given in the production of magnetic tape, in which broad sheets of acetate are coated with a layer of iron oxide and then cut into ribbons up to 2,000 feet in length. In this case, quality control is necessarily linked with electronics, since the recording characteristic of each reel of tape depends upon absolute uniformity of the oxide layering. Samples from every batch are checked to standards of frequency and level. Prior to the introduction of nucleonic gauges, control of the layering rested largely on experience in processing. The machine operator carried a heavy responsibility in maintaining visual assessment of the operation of the coating bath. Physical measurement of the product could not be carried out before the coated sheets had passed through the drying cabinets, at which stage test strips would be taken and micrometered. The value of continuous measurement given by the nucleonic gauge is particularly evident here. 2 measuring heads reach each half of the uncoated sheet. 2 more heads read the coated side. The output of each pair of heads on each side is combined to measure the difference. This is the thickness of the coating. By means of a switch, the operator is able to observe any deviations from standard on either half of the sheet. From this, it can be seen that it is relatively simple to link the measuring gauge with automatic control of the machine. Similar results are obtained, and the same opportunity for automatic control exists if the backscatter method of measuring the coating is used. Here again are some of the tools on which traditional quality control relies. All of them are associated with the human element. None of them are easy to link with automation. In an age when industry strives to employ labour to greatest advantage, they frequently tie control to manual operation of the processes of adjustment. Ekco Nucleonic gauges can be supplied in conjunction with automatic control units, which are easily set up to maintain required standards. The servo unit provides signals which operate reversible motors, handling control equipment ranging from small doctor blades to the largest screw-down mechanisms. So, whether the job is small or large, it comes within the compass of service of the Nucleonic gauge.